Good morning. Today we are working on adding and subtracting fractions, but our main focus is actually adding and subtracting rational expression. This is TEKS 2A.4F. So we're going to start with adding regular fractions. So one of the main things you have to remember when you are adding fractions is that your denominators must be the same. If the denominators are not the same, then you have to find the least common denominator. For this problem right now, my denominators are a 2 and a 3. So what is the least common denominator between a 2 and a 3? It would be a 6. So I want to make both of my denominators 6. So for my first fraction, what do I have to multiply by 2 to get a 6? I'm going to multiply times 3. Now, if I multiply on the bottom, I must also multiply on the top. Because this is just like multiplying by a 1, because 3 divided by 3 is 1. The second fraction, I'm going to multiply my numerator and denominator by 2. So now I'm going to distribute the 3x into the 3. I get a 9x. And this is a plus sign, so it's a positive 5x times 2. So 5x times 2 is positive 10x. When I combine those, I get 19x divided by 6. I do have to look if I can reduce it, and in this case, I cannot reduce 19 over 6. So this is my final answer. The next one, now we have a denominator that is, I have a 2 and a 3x. So what is my least common denominator of 2 and 3x? That would be a 6x. 6x is the first term that they both can go into. Well, on the first fraction, how does 2 become 6x? Well, I multiply it by 3x. And don't forget, whatever you multiply on the denominator, you must multiply on the numerator. The second fraction, I multiply it by 2. And if I do it on the denominator, I do it on the numerator. So my denominators now are both 6x, which is why I can write it as one fraction. So we're going to go ahead and distribute 3x times x, we have 3x squared. 2 times 2, we have a 4. Now, can I reduce anything? Can I factor out an x from my numerator? Is there any greatest common factor? The answer is no, so this will be my final answer. So again, this was just review of adding fractions and finding the least common denominator. And now we're going to get into the rational expressions. So with the rational expressions, we're still looking for a least common denominator. So on my denominator right now, I have an x and I have an x plus 2. So my least common denominator is an x and an x plus 2. So the first fraction, it already has an x, so it's missing the x plus 2. My second fraction already has the x plus 2, but it's missing the x. So now on my numerator, I distribute. I get 3x plus 6. This is a positive 4, so positive 4 times x is positive 4x. Combine like terms, and I have 7x plus 6 over x times x plus 2. My numerator has no greatest common factor, so there's nothing that's going to divide out. But the one thing we have to go about and talk about is the holes in this problem, these domain restrictions, because when I have variables on the bottom, when I have these x's on the bottom, and I'm talking about this x right here and this x down here, these make domain restrictions. I can plug in any value for x except when my denominator is equal to 0. So we always come back and we say, when x equals 0, it's a domain restriction. The second one, when x plus 2 equals 0, it's a domain restriction. Well, solve for x. Subtract 2 from both sides. x equals -2 is a domain restriction. So when we put them here, it's just an equal sign. But when I rewrite them here, I'm actually telling you that x cannot equal 0 and x cannot equal -2. So I add them or subtract them, and I always have to remember possible domain restrictions. So we're going to do it again. My denominator has an x minus 1, and it has a 4. So my least common denominator is x minus 1 times 4. Now, one of the different things for this problem is this minus sign. If you have a minus sign, the easiest thing to do is to distribute it to everything after the minus sign on the numerator. So if this is one term, this is going to change to negative. If this had two terms, you would distribute the negative to everything up here. So I'm going to actually distribute the negative to the 5x so I can change that to a positive. On my first fraction, the denominator is missing a 4. My second fraction, the denominator is missing an x minus 1. I'm going to go ahead and distribute on my numerators. I have 6 times 4. Now I have a negative 5x times x. I get negative 5x squared. Negative 5x times negative 1 is positive 5x. I'm going to go ahead and rewrite this in the correct order. Now for my numerator, I check if I can factor it. And I could pull out a negative 1 if I wanted them to be a positive 5s, but I don't have to. I can actually leave my answer just like that. Okay. Now we just go back to talk about domain restrictions. Remember your original fractions. If you have an x on the bottom, this one does not have an x. So you set this denominator equal to 0. So x minus 1 equals 0. Add 1 to both sides. X cannot equal a positive 1 because it is a hole in the graph because it causes a division by 0. Okay. Couple more questions. So this one, I see my denominator is an x plus 7 and an x minus 8. What's my first fraction missing? X minus 8. What's my second fraction missing? X plus 7. And it is a plus sign in the middle, so I don't have to change any signs. Again, we're going to distribute on the numerator. I have 3x minus 24 plus 2x plus 14. Combine like terms. You get 2x plus 3x. We have 5x. Then we have negative 24 plus 14 gives me a negative 10. Now I always have to factor out my greatest common factor. So on my numerator, what number goes into 5 and negative 10? Well, the answer is 5. So I'm actually going to factor out a 5. And I'm left with x minus 2. Now the reason we do that is also to see if anything on the denominator and numerator are going to divide out. And in this case, nothing does. So there's my answer. Where are my domain restrictions? Where are my holes in the graph? Set your denominators equal to 0. X plus 7 equals 0. Subtract 7 from both sides, you get x equals negative 7. X minus 8 equals 0. Add 8 to both sides, you get x equals 8. So because those are the restrictions, x cannot equal -7, and x cannot equal a +8. Last question of the day. Now this one starts off with this x squared minus 25, which we should be able to look at that and see that it is a difference of squares. A difference of squares means we can take the square root of the first one, we can take the square root of the second one, and it's a minus sign. So that actually factors to x plus 5, x minus 5. So now, what is my least common denominator? My least common denominator is x plus 5, x minus 5. What is my first fraction missing? Nothing. It already had both of them. So we're going to bring down the 40. My second fraction had an x plus 5, but it's missing an x minus 5. Okay. Distribute. You get plus 4x minus 20. We're going to go ahead and combine like terms. So 4x, and now we have 40 minus 20. 40 minus 20 is a positive 20. So 4x plus 20 over x plus 5, x minus 5. Now my numerator has a greatest common factor. What number goes into 4 and 20? A 4. So we're going to factor out a 4. So when we factor out a 4, we're left with x plus 5 divided by x plus 5, x minus 5. Now look what we have here. We have a common factor on the numerator and denominator, which means x plus 5 divided by x plus 5 is actually 1. So we're going to go ahead and rewrite this. Now 4 times 1 is just 4, and x minus 5 times 1 is just x minus 5. So that is your answer, and all we need left is our domain restrictions. So we take our original denominators. You see why we can't just take this one, because I'm missing the other one. So take both of these. Now I don't have to do it twice because it's already there. So x plus 5 equals 0, x minus 5 equals 0. My answers are going to be that x cannot be equal to -5, and x cannot be equal to +5. Okay? Thank you for watching this video. If you like it, give it a thumbs up and subscribe to this channel. And I will have more videos on adding and subtracting rational expressions.